Okay, so let's start with the next exercise, that is on logistic regression. Now this is also something similar to the linear regression, but it is different in a sense that here we are going to decide about the binary. That means either this is true or it is false. So that is what the objective of this. Now let's start with the exercise. Now here again you know about the title that we can give, again the remark that should be given so that you know that what is this program about. Then what we are going to do is we are going to find out the logistic regression with Titanic data set. Now Titanic data set, as all of you must have seen that movie also, Titanic movie, where the ship got drowned in a sea. That was in 1911 or more than 100 years ago, and some people who were on board, they survived, but most of the people died. So that was so we got the data set. Now it's available on the internet also, so you can download the data also from there. So that was the data that we are going to consider. Now this is the heading that we have given. The data we are considering is the Titanic data set. This is a very famous data set and often used for various applications of machine learning classification. We are trying to predict the classification, survival or deceased. That means whether he has survived or he died. We will observe the data, analyze it, visualize it, clean the data, build a logistic regression model, split into train and test data, and make predictions, and finally evaluate it. Okay, so this is our objective of doing this particular exercise. Now as we know that we have to import all the libraries. Now before that, let us first clear all the outputs. So how we can do it, restart and clear the output. So once we click on this, we will clear all this. You can see that it got cleared now. Now one by one we can also start working on it, running it. So when we run it, nothing will happen here because it is just a remark. Again, nothing is going to happen here. Again, this is just for information. We are trying to predict the classification, survival or deceased. Again, remark. This again is a remark. Now we are going to import our libraries. That import numpy as np, import pandas as pd, import matplotlib.pyplot, because we are going to draw various charts and graphs. Cboard is also for that, and then matplotlib in line. So once we run it, you will see that it will take some time, and then for importing all the libraries, and then so it is imported now. Now we will process by importing the Titanic data set. We have imported all the libraries. Now we have to import the data set that we are going to work on. So after that, we will be checking the head of the data frame. So we can run this also. Now this is the data set. Data set is, we can take it in this data frame, and whatever name you want to give, you can give it. Here we have given the name as Titanic_data, and it is this data set, Titanic_csv.csv. Again, the path that wherever you have kept your file or this data set, you can give that path. Titanic data is equal to pd.read_csv. So once we import the data, then we can also check the first top 5 rows of the data set. So for that we have to simply run this, right? So once after importing, 5 top records are being printed or displayed here, right? So you can see that all these 5 records are available to us here, and the variables, the data items that we have is survived. You can check here one by one that this is unnamed, this of course index number, this is the passenger ID, survived, P class, passenger class, name, sex, age, sibling, spouse, parent, child, then the ticket, then next is ticket number, fare, cabin, and then of course the cabin, and then embarked. So which class is this, SC, whatever name. Now here you can see some nan. Nan means that not a number. That means this is something has to be done for this. So this is how you can check your data set. This again is the one that we discussed earlier also. This is data exploration. So you are exploring your data. You are trying to understand your data as closely as possible. This is very helpful. And we will do it number of times in different ways. Now after doing this, we can also check the tail part of this. Like we have seen the head for top 5 records of the beginning. Similarly, the last 5 records of the data set. So for that we can write Titanic data dot tail. So once we run this, you will see that last 5 records will get displayed here, right? Similarly, these fields are going to be same. Now here you can see that most of the data that we come across has missing data, because the NaN that you have seen, or zeros, sometimes you can see that zeros, that means there is no data. This is all possible. That is why the data cleaning is very important. If you remember, we talked about the data wrangling, data pre-processing, all that, those things, which is going to be used here. So you can see that most of the data that we come across has missing data. We will check for missing data, also visualize them to get a better idea and remove them, right? So we can again, run this. Then we want to know that how many passengers are there. So how to check that? Print number of passengers in original data set. This is a kind of a remark or that you can give. Then plus string, because we are converting the number into a string for our printing purposes. So string, then within bracket len means the number of passengers, and this is our data set, and this is all index, right? So this is how you can write the code for finding out the number of passengers on board, right? So once we run it, you will see that you will get this kind of a response from the system. That is, number of passengers in original data set is 891. So total number of passengers on board were 891, right? Now we are going to write this code, that is Titanic _ data dot info. That means we are trying to get some more information about the data set. So for that, you just run this command and you will get these details. That means unnamed, passcode, whatever fields were there that we have seen already, and then you can get some more detail about the same data set. And 891, 891 that you are getting, age is 714. That means not for everybody. Cabin is 204, embarked is 889, like that. So whatever is the status of your data, you will get all that in a summaries, right? Now here we are going to check the data types. What are the types of data these are? So for that, you can again run this and you will get, again, this is integer, this is also integer, then this is on object, right? So object, float or integer, whatever. Whatever type of data is there, you will get the details of that, right? Now again we are going to get some more information about the data. So we can write Titanic data dot describe. Once we run it, you can see that some statistical information has come which again will be helpful to us. So count, mean, standard deviation, minimum number, 25 percentile, 50 percentile, 75 percentile, all that will be available to us. And again the variables which are there. So this way you can get better idea about your data set. As I said, that this is very information for our own knowledge. The next is that with following code we can check how many male and female passengers were there. Now out of that we got the number 891, all right, but then we don't know how many males and how many females were there. So for that, to get that, we can write this kind of a code, that is SNS dot count plot, right? Now this is coming from your matplotlib and of course the C board. SNS dot count plot, x is equal to survived. That means how many have survived, and what is the data set? Titanic data set, right? So once we run this, you will see that you are going to get this kind of a graph. Now this shows that survived, and here you are going to get the number of counts. So the 0 means that this female, 1 means that males, right? This is how the data was codified. Now next is that with the following code we can check how many males and how many females pass. Now this here we are not getting that. Here we are getting only survived and died or deceased. So this is the only difference. The next we are going to get that how many males and how many females were there, right? So for that, SNS count plot X survived hue is equal to sex, that is what is it, whether they were male or female, and data again is the same data set. So we can after running this, you will get another graph somewhat similar to this, which is like this. Now here you are getting that survived, but male blue and female orange. So you can see that so many males have were there, and so many females were there, and like that so many males survived and so many females survived out of the total, right? Then with following code we can check the distribution of passengers classes. That means how they were distributed on the different classes, passenger class, like we have the train or maybe in aircraft, that we have different classes of passenger. Similarly on ship also there are different passenger classes. So we are getting counting that how many total number of people who have survived and what are their passenger classes, and the data set is this. So once we run this, you can get this kind of a graph, which is very much again self-explanatory, that survived 1 class number 1 blue, 2 orange, and 3. So this is how, and this is also very obvious, because first class is always costlier, second is slightly lesser costlier, and third is cheapest, right? So this is how you can say that the people who were there, they were distributed like this. This is the total number of count. Total number of count is like this, and then you can survived and deceased, right? Again we want to know, this is all exploratory. We are not doing any analysis on that, but this is for our own information, which is again very helpful. So with following code we can check age wise distribution of passengers, right? So this Titanic data set, age, and then plot histogram. Hist means histogram. So again we can run this code and we can run it. Let's see what happens. So once we run it, you can see that this is the kind of a graph that you get. That means with following code we can check age wise distribution. That means what is the bit. So you can see that between age 20 and 30 there were maximum people, right? 20 was maximum, 30 was slightly less than that, and like that. This is how the total number of people age wise have been distributed. So this again is a very informative information. Then with following code we can check fare wise distribution of passengers. What fare is very important again, like how much fare was there for these different classes. So Titanic data, fare, then plot histogram again. So again we can run it and you can get this kind of a, so this is how the this was cheapest, then slightly costly, and then this is the first class. So this is how you can get the different types of fares which were there. Then the next is to have a little improved graph. Let us add some code to the previous one, like Titanic data, fare, plot, history, and then bins. We can create some bins, and the fixed size is 10,5. That means that is the size of the graph that you are going to have. So we can again run it. So let's see. So you can see here that this is slightly more detailed information that you are getting, right? Fare, plot, hist, bins. These are different bins, 0 to 100, 100 to 200, 300, like that. and this is of course the cheapest. So you can, I mean, the costliest one is coming here. Very few people were there in the costly, or rather passenger class, first class passengers, right? So this is again, these types of information becomes more and more useful for the analyst. Now next is that we may note that the data info shows that we have done analysis for every possible variable except name, which is only for information printing. So now let's analyze the count of siblings or spouse on board the ship. Following command may be used for this. So now we want to know the siblings or spouse, because there is quite likely that husband and wife may be there, or husband and children are there, or maybe women with the children are there, whatever. So we can again write some simple, and all the time you will see that the code writing is very small. It is, the remarks are much bigger than the code. So SNS count plot x is equal to sip. This is a variable which you must have seen above. If you see the, here you can see here the sip, sibling, spouse, right? So this is what we are going to further check. Like here, sip. So data is again Titanic data, and then when we run it, you can see that again you are going to get this kind of a, so sip, like that is sibling and spouse. This is how the data is distributed, right? Now, so we have all the possible analysis with Titanic data. Now let us try to clean the data. So we have seen whatever best. I mean, if you think something more can be done, you can try that also, but I think this much is sufficient for our analysis for the time being. Now, so we have all the possible analysis with Titanic data set. Let us try to clean the data now, so that all the null values and nan null values, that is zeros, and nan means not a number, are either removed or clubbed, so that the data becomes easily analyzable, better known as data wrangling. Now this is what the data wrangling, if you remember, we have learned in the earlier tutorials. We can also create a separate section for this. So we can create a section like this, data cleaning, a separate heading has been given. Now we want to fill the missing age data, instead of just dropping the missing age data. So we just want to see that is there any data which is missing. One way to do this is by filling in mean age. I mean, here the analyst decision comes into play. The analyst has to decide that what is to be done with such cases, whether you take the average and then fill it, or you want to drop it, or what action you want to take, because something has to be done. So the mean age of the all the passengers, or imputation that can be done, or following code may be written to get the false null values. So this is how you can get the false values, null values, right? So Titanic data dot is null, that means it is a null data. So we can run that. Yeah, we can run this also. Remark, nothing will happen, but yes, you must run it. This also we must run. Then when we run this, you can see that you will get that this information. That means, false, wherever, because the data is quite lengthy, so wherever there is a false situation, it will write there, right? So this is how you can get more information about your data set, because you can't scan each and every row of the data. So that is how, just by writing one line of code, you can get all that. So there are 891 rows and 13 columns. So out of this, because it starts from 0, so it goes up to 890. And so many, say false cases are there in different variables. That's how you can find out. Now this shows the true or false values of individual fields for each passenger, right? So we can run this also. Of course, this is again remark, so nothing will happen. Now we can get number of null values for each. That is, following code may be used for this. So we now want to know that number of null values for each of these. So Titanic data is null. dot sum. So we can get just one figure sum after getting the sum. So this is how you get passenger ID 0, survived this 0. In age there are 177 cases which are having the null values. Similarly, in the cabin you have the 687 cases which are having the null values. So this is how you will get it. So just by writing just one line of code, you are going to get this kind of information, which is again useful. This shows that 177 passengers whose age have null values and 687 passengers have null values in the cabin, and only 2 number is in embarked, like here, right? So this is the kind of information that now we are exploring further and further, and we are getting more and more information about the data set. Now you can run this also. Again, nothing will happen in this. Let us now try to find age-wise occupancy in different passenger classes. Because we have talked about different passenger classes. First class number 1, 2 and 3. And we want to find out the age-wise occupancy in each of the classes. This can be found with a box plot by writing the following code. So box plot you must have seen or read in your classes, or maybe in some other line. So this is how you can go. So by running this, nothing will happen here, but definitely for getting the box plot, sns.boxplot, x is equal to p class, that is passenger class, y is the age, that is age wise you want, and data set is Titanic data. So once you run this, you will get like this kind of a block. First class you will get that these many numbers, second is this, and third is like this. So this is how you can get the age wise analysis of your data set. Okay, now the next is that we can notice that highest aged people, this is aged people. So this is the highest aged people are going to be in the first class. Slightly lesser aged people are in second class, and youngest people are in the third class, right? So this is how you can, this is again information, right? So we can get this additional information by getting the box plot. Again running this cell, we can note this one of course we have done. Then we have already seen that there are so many null values, particularly in cabin columns. So it makes sense to drop the cabin column. That means if the number of nans or such cases are there, which are quite a number, then there is no point in keeping it, because unnecessary you are having more and more data, and the time taken for doing the processing will be definitely more. This is also known as dimensionality reduction, because we are reducing the number of variables. So this is, we have read that also, dimensionality reduction, we can reduce it wherever we feel that it can be applied. So then so it makes sense to drop the cabin column, and this method is called the imputation. So first let us check the data. So let us check the data first, and we can see, this is of course nothing will happen here, but here again we are checking the data with the head command that we have written here, and we can see that how many nans etc are there. Now so that to drop the cabin column, we can write following code. Now that column we want to drop, that means we do not keep it in our active data set. It will not be removed, but we are just dropping for this purpose. So that means it will physically be there, but we are not considering for our calculation purposes, right? So don't keep that in mind. Now, so to drop the cabin column, you can write following code, that is Titanic data dot drop. That means simply with drop you are going to drop this particular cabin. Axis is 1. That means from that x-axis, that is the horizontal variables that you have seen, where you have seen the passenger class and siblings and all that, sex, etc. And in place is equal to true. That means we are dropping, and this is going to be true. That means it is going to be implemented. So we again run it, and you can see that it is dropped. After doing this, we can check again just to find out whether cabin column has been dropped or not, because after all we have to be sure about it. So you can again run this, and you can see that the cabin column is not there in this now. Right? You can check it, go back here and see that the cabin column is not there because it has been dropped. Earlier it was there. If you want to check it, go back, go earlier, and you can see that where is that? This cabin column is there, right? So this is how you can do that and check it. Always keep checking. This is again very important, because quite likely that either you have written some wrong code or some problem could be there. Now, in order to further drop the nan values for column, we write following code. Now we can check. Now some more nans are there, so we can drop that also. And for that, we can write this code like Titanic data dot drop na. Na means that not a number, nan. So not the complete nan is written, only na that indicate that we are dropping the nan items. In place is equal to true. This indicate that yes, it is going to be true. So again we can run it. Right? So it has this has been executed. So with this we have done some amount of data wrangling. Now this whole process that we have done is known as now data wrangling, which again we have studied earlier, which can be checked with the following code. And again we can check it like Titanic underscore data, that is the data set, is null dot sum. So again we can get some figure about it. So we can run it. So we can see that now everything is gone. There is nothing like nan etc. in this, and all those problems have been removed now. So this is how you can keep on checking, keep on doing, and then be sure that yes, whatever you wanted has been done. Now next is the data is absolutely clean now, right? So again we can run it. Now if we check, we find through the cabin column has been dropped, still we have a lot of string values, right? Because it is always very important that try to keep your data in a numerical, so that not only your processing will be faster, but string may not be required, because that is just for the information purpose. So why to have the string data in your data set? So that is the objective. So try and remove wherever you feel that the string columns are not required, whether it is name or it is like cabin or male female type or whatever. So if we check, we find though cabin column has been dropped, still we have a lot of string values which can either be removed or converted to categorical values, as can be seen here. Now in case you still want it, you convert them into a categorical value. Now this is again something which is very important. So again here you can see, we will check it with the, and here since we have given the 2 number within the bracket, that means only 2 top record. 2 records from the top will be shown you here. Run it and you will see that only 2 records, 0 and 1, will be displayed to you. And with all those columns which are remaining, only with the remaining columns, right? Now here you can see that we know that the logistic regression accept only one value out of the 2. That is what the premise on which we started. So it shows, it tells you that only one out of 2, because it's always the binary. So we need to convert the remaining data accordingly. So for that we will use pandas, and following code may be written. So again we can run that. Let's see what we are going to do now. Now here we can see that the pd.get dummies Titanic data sex. Now as we know that the gender is either male or female, so why to keep both of them? No, so you can always drop one. So let us see how we can do that. Now here you can see this is the detail. That means female means female 0, male 1, like that. So here you can see that all the data is being displayed to you, right? This is the index number, of course. So female, male, like that. Now, after writing the code, if we press shift and tab together, we will display as shown above. So shift plus. Okay. Now we have two columns. So, one is our male, and this is for female. We don't need two columns, right? That's what I was telling you. One column can easily tell us whether the person is male or female, because there is no point in having two columns. One is telling only female and the other is telling male. So one means male and 0 means female. So only one column and the indicator is 1 or 0. That will do. So we can conveniently remove one column. To do this, we can write following code. So PD, that is pandas, get dummies, Titanic underscore data, that is the data set, sex is that column, and drop first is equal to true. So we are dropping 1 out of the 2. Now again you can see that we can run it. This also we had not run this. Again we can run here. So that means now we are getting only one column because the other column has been dropped. So which means that male is 1, female is 0. So like that you can see that all those males will have the 1 as the code and the other is obviously female, that is 0. So 712 rows and 1 column, right? Out of 891 we are left with only 712 rows. Now similarly we can see in embarked column there are 3 categories, CSQ. These can also be clubbed like we did in sex column. Now here we have removed one column. On the similar lines we can reduce at least one column out of the 3. So there are 3 categories CSQ, and there can also be clubbed like we did in sex column by writing following code. So let us go back and check our data so that let's be sure that where is that. Now here you can see the embarked. Now embarked is again 3 columns were there. So CSQ, instead either it is C or S or Q. So instead of the CSQ we can keep only 2, right? So that is what the purpose is here. Yeah. So we can run this. Embark is equal to pd dot get dummies Titanic data. That is the data set embarked. Embarked is the name of the column, and then when we run it we can get this. And again when we run it you will see that the C, Q and S are appearing there, right? We can check like this, embark dot head 5. Again we are just checking 5 records of the top, so that we can see, right? Now here we are having all the 3 columns, that is C, Q, S, which were there appearing of course in one, but there were 3, right? So we can now in this the passenger can travel in one of the 3 classes, either C or S or Q. As such we can have only 2 classes. The third will be by default. So let's remove that also, column C. So column C we are going to remove now. Now this can be run. So again now we are going to, this can be done in the same way as was done in the case of the sex. The code is embark is equal to pd dot get dummies Titanic data set embarked drop first is equal to true. So first is C, so that is why C will get dropped. So we can run it again, and that is done, that is executed. Now next is that now we can check. We can check the position with this code. Now embark dot head 5. So 5 records can be checked now, and we can see that now the C has been removed. C has been dropped. It's not there, right? So only by default we can say that the third which is not there is C, right? That is how this again is a type of dimensionality reduction. And this is very helpful. Now we are seeing that we were having 31 columns and now we are reducing, right? so that our processing and we can easily manipulate the data the way we want. Now next is similarly we can do it for passenger class, where there are three classes, 1, 2 and 3. We can do by writing the similar code here also, that is PCL is equal to pd dot get dummies Titanic underscore data p class drop first true. So we can again do that by running it, and here we are getting, if you check again by displaying it, so you can see that no, because here we had drop first, we have given this command, so that is why the first one has been dropped. So only 2 and 3 are getting displayed, and this is with the top 5 records that we are seeing this part, right? PCL is one of the variable that we have seen. Now let us concatenate so that the new fields are added to the pandas. This can be done with this code. Titanic data pd.concat Titanic data sex embarked PCL etc. This of course is remark, so nothing will happen as such. Now we can again check our data, that what is the shape now after doing all this. So you can see that we were having so many fields, now we are reduced, the data set is reduced only with these many columns. Now we'll do something more on this now, but for the time being, that is why we must keep checking the data, because it is not going to be, it will be more it will give you more confidence that yes, you are on the right track, things are happening as you wanted. So we can now drop all the unwanted fields so that only required data is available for the necessary analysis. This can be done with the following done. Now you will see that further we are going to reduce number of columns which we are seeing here. Now what we are going to do, Titanic data dot drop sex name PC P class embarked pass passenger ID ticket, axis is 1, that is x-axis, in place 2. That means we are going to drop so many columns just in one shot, because Titanic underscore data dot drop. So once we execute it by taking the cursor here and running it, it has been executed, and now we can see check our data set. So by again the same command which we have been using, and you can see that out of so many columns that we have seen here, like here, 1, 2, 3, 4, 5, 6, 7, 8, 9, so many out, and I think some more after ticket, fare and embarked. So many columns, almost 11 columns, and now we are left with only 1, 2, 3, 4, 5. So this is the dimensional, and all this process is known as data wrangling. So we have been able to minimize the unnecessary fields, and now still we are able to do whatever analysis that we want to do, right? Now the next heading is training the data. Now after doing all this, our data has become almost perfect. That is why the data wrangling is very, very important. Now I think you will be able to appreciate the importance of data wrangling. So this is how you can do the data wrangling. Now we are going to train our data. Now since we have to check the probability of survival of passengers, we have to consider the variable for logistic regression, that is prediction of passenger survival. We have to write following code, right? Because we have to see that whether the person has survived or not. So that is what we are going to do now. We have to check that. So for that we have to train our data set. So x is, we can run this also. Yeah, x is equal to Titanic data dot drop survived is equal to x is equal to 1, y is equal to Titanic data survived, and again we can run it. So this will be again executed. Now we need to split the date in the ration in which we want to now we want to split the data. It is not the date, it is the data. In fact, we can write it data in the ratio. Now we need to split the data in the ratio in which we want to segregate the data in that ratio. We are taking 70% for training and 30% for testing. So that is the ratio. Now it again, as I said earlier also, that it is up to you, the user or the analyst, that what ratio he wants to keep for training and testing. So 70% for training and 30% for testing, for which we write the following code. So we can again run this code. Now after running this code, you can see that from sklearn model selection, import train test split. Now we have to import this because this is a sub library of sklearn, right? And sklearn is a model. This is the first library, and this is the library of this model selection. So this is sub library. That is why we are from sklearn model selection we are importing this, right? So we have imported this now with this, and we can execute it also. Now we are going to do that actual segregation. That means x train, x test, y train, y test, train test split. Then x comma y comma test size is equal to 0.3 because we have kept 30% for testing and random state is 10. So we can go for 10 iterations. Now that again is something which you can keep changing also, and it is up to you to decide that how many iterations that you want to give. That of course you will get it with your own knowledge about the type of data, etc., etc. So we can execute it so that the data gets split like this, right? Now the next is, this code will divide the data in the specified ratio with the number of iterations to be done, that is 10 in this case, that is the number of iterations, and we can give any number from 1 onwards. So you can give 0, you can give 1, whatever number that you want to give. There is no hard and fast rule for this. We can write the following code to check the division of data, and for that we can again we can run this also. Then we can write the following code. This way also we can run. Then we can check the length of the X train data. That means the data which has been transferred or segregated into X, that is for training purposes, what is the length of that we want to check now. So we can, by writing this, we can see. So out of this 891, 498 records have been put into for the training purposes, that is X train, right? So this is how you can find out. Now next is, similarly we can check the value for the test data also. That also you can check because the remaining is going to be for the text. So we can run that also. Now together, if you want, you can see that after removing all those removed records, you can see that this much data is shifted for the testing purposes, right? So the total data has been segregated like this. Now from sklearn linear model, import logistic regression, because that is our ultimate objective. That is what we wanted. That is our exercise, logistic regression. So we want to, from sklearn we are going to import the logistic regression. So this also we have to import. Again, you can see that everything that we have to go by using the libraries and sub libraries. We don't know what is there in the sub libraries or libraries. I mean, that we need not know also, but we must know that how to use it. That is our job. So log model is equal to logistic regression. So you can again run that. See that also has been executed. Now we have to fit the model. Now the model has been created, but now we have to fit the model to train the data, for which following code is to be written, right? So this is how you can write the code, and you are clear that now the model has been created and we have to fit the model. So log model dot fit, whatever model has been created here, fit X train, Y train. So we can run that, and you can see that this is how the logistic regression. See, this is for information. It has, so that if somebody wants to go into detail, he can go for that. So C is equal to 1, class weight is none, dual false, fit intercept, all such things can be given more for information purposes. This, of course, with passage of time, you will get to learn about these things. Now we will write the code for prediction as mentioned. Now we are going to write the code for the prediction purposes. So we can run this also. Then predictions is equal to log model dot predict X test. Now we are going to test it because model has been created. We have done all those things earlier. Now we are going to predict it. So when you do this, to generate the classification report, import it and from the sklearn matrix. But how to check it? So for that we have to import the matrix here. So from sklearn.matrix import classification report, right? So this also we need to import from the sklearn, and that is from matrix. So we can again, this was run, this is also to be run now. So we can import it like this, that is also done. Then we can go for printing the classification report with following code. Now classification report has been imported, so now we have to print it. And everything, I mean again I repeat that we are not writing any code for report as such. It is all coming automatically with the help of the libraries. So you can simply, run that also. Then print classification report y-test predictions. So simply just by writing this code, you can see that your report is getting printed. Precision, recall, F1 score, support, whatever data. And this is a standard report. Accuracy, macro average, weighted average 0.79. So accuracy is 0.70 and 214 is the support. So all these things are very much clear. I mean, this of course with experience you will get to know about it very comfortably. You will start understanding all these things. So this is how your classification report has been printed. Now we can see the weighted average of F1 score is 0.79. Now you can see that here the weighted average is 0.79. Now again I would say that if you run it again, these figures may change. So do not go that in first on the first run you have got some value, so you will get the same value again and again. Because that is why the iterations may change. All these iterations. So don't go here. Earlier when this was run, it might be 0.79, but this time we are getting 0.77. Right? You can see here. So that is what the difference. So do not get disturbed by that. So now here we can see that the weighted average of F1 score is 0.79, that is 79%. We can now check whether this output is correct or not by using confusion matrix. Now confusion matrix also we have studied, and that is something which is very helpful in removing the confusion. So that is why we are going to use confusion matrix for the purposes of understanding it better. So we run this again because it's a remark. For this we need to write the following code. Import confusion matrix. We can run this also. Now from sklearn matrix import confusion matrix. So simply import confusion matrix and your job will be done here. See, confusion matrix y-test. Y-test is the data that you have kept for the testing purpose, and predictions already is available with you at the top when we have gone for the predictions, right here. So you can see that confusion matrix y-test and comma predictions. So we can run this also. So you can see that this kind of array you must have, if you remember in confusion matrix we were getting this 2 by 2 kind of a matrix. So 121, 361, 29, this is the kind of matrix that you get. So to find accuracy we need to import accuracy. Now we want to check the accuracy of this also. So we need to import accuracy from sklearn for writing the following code. So to check that, run this, and then from sklearn matrix import accuracy score. So we want to check the accuracy of that also. So for that we can run this. You have imported the accuracy score, and now we are going to check the accuracy y-test with prediction. So run it, and you will see that you are going to get this 70%. Again, if you go back, our calculation also said the 70%. Where was it? 70% we got. In the calculation we got it somewhere. Where was that? think we are not able to identify. Anyway, let's not waste time. So we got the 70%. Now this array may be explained like as shown in the left, that is now to cross check the accuracy we can again, like if you remember the formula of confusion matrix, 121 plus 29 divided by all the numbers which are available in this, that is here 21 plus 3 61 29. So you can totally divide it and you will see that this will again give the result as 70%. You can check it, take your calculator and then do it. So you can see that 70% we got it from this accuracy score and 70% we got with this calculation. So both are matching. This confirms that our algorithm is correct, and thus we can say our prediction is correct, right? So this is how we can do the logistic regression. This of course all remarks, but let us run that also. We have got the total like this. This will again give the result like this. So once we do the calculations etc, you'll get this, and thus we can say our prediction is correct, right? And now this completes our logistic regression, and which we must also check our PWD, that is present working directory, where actually this program has been saved. So we can run that also and we will get the user Deepak. This is the directory where the Python was originally installed, and all the programs that we are saving or creating are also getting saved there. So this is how this completes our logistic regression. Thank you.